As we were talking about before, the way that we extend a game object in Unity is by adding a component to it. But because the developers can't create every possible component that we might want, because each component might have unique behavior, they create a special kind that allows us to write our own code to do what we'd like it to do. This is what we call scripting. And part of the reason that we also do that is because, Unity itself is written in C++, just like Unreal. And these game engines are pretty complex, but the issue is that writing most of your code in C++ is kind of a tedious thing that causes a lot of problems. And so if you are a game designer or a level designer, you don't want to have to write in C++. You'll go down in the weeds, getting stuck with memory problems and things like that that C++ is notorious for. So in essence, many of these game engines have added scripting languages in order to make it easier for this kind of development, especially in the areas where performance is not an issue. All of the rendering code and all of the things that make the game engine work in a fast way has been done in C++, and then they give us interfaces in these scripting languages in order to control those things which don't have the same performance requirements. So as we said, we're going to add a component to the game object in order to be able to extend it. And let's go ahead and do that right now. So we'll click on Add Component, and then I'll scroll down to New Script, and then it's going to let me type in the name for the script, and I'm going to call this Planetary Behavior. Now, because I've selected Lab 1 here, when I create and add this, it's going to create the script here in Lab 1. Or it should, but it didn't. So let's grab it and drag it into Lab 1. This way our assets are in the right location. So now we have it in the right location. Okay. If I double click on it here, or if I come over here to the planetary behavior script and double click on it here, it will open up Visual Studio for me. And this will give me the code editor for writing the code for writing the script for this object. The first thing you should notice is that every game object is going to every scripting game object is going to inherit from Monobehavior. And it's good to look up the documentation for this if you haven't yet, if you haven't gone through the reading part, because the API shows you the different methods that you can use and you can override to customize the way this script works, because there's a lot of things that might have to happen, like interacting with other objects and things like that, and there's specific methods defined in specific ways that you need to write if you want to get those actions. But by default, all scripting objects are going to have these two functions: a start and an update. And the start is called at the beginning of the frame. Okay, well, really before the game is really drawn, when the object gets loaded into the level, it's going to call start. And this is where you would do your configuration. If you think about object-oriented programming, you might normally initialize variables in a constructor, but since we don't really have constructors here, we're going to do most of the initialization in the start method. The update method is a method that gets called every frame, and we'll go into more detail about what frames are exactly at a later date, but just know that it's a way for the game engine to ask your object, how do you want to change based on the amount of time that's elapsed? And so we can define that method here in the update method. Now, one of the important things to understand is that scripts that are written with Monobehavior are able to interact with the Unreal editor depending on how I define things. So let's say that we want to make the object move to the right every frame. Okay. Well, the way that we would do that is by accessing the transform. Okay. And if I start typing, you'll see the transform. And the transform is going to correspond directly to the transform that I have over here. So I'll have a position, a rotation, and scale. So I can say transform.position. Okay. And then it's telling me what type it takes. And I can say something like plus equals. Actually, do not do that. Equals new vector 3. And I'm going to say transform.position.x plus 1f. Transform.position.y. Transform.position.z. Now what this is going to do is every frame it's going to add 1 unit to the current x position of the transform. And as we get a little bit more into C sharp, we'll see why I couldn't do the plus equal like I wanted to. And I'm adding 1 unit. Now this is going to actually move way too fast for me to see. Okay, and I haven't done anything related to time, but let's just go ahead and save this. And then we'll come over to my game and we'll hit play. And we'll see what happens. Well, you saw it maybe briefly there for a second. It's just moving way too fast. What would be nice is if I could control what this speed is. All right. And the way to do that is to make a public field. And we will call this x speed. Okay, so it's going to tell me how fast it's going to move in the x direction. Okay, and now instead of having this one f here, I'm going to put x speed here so that I add it. Now, if I come back over to Unity, what I'll see is that this float that I've added here is going to become part of the interface. And you'll see that it is now right here. So x speed. You'll notice what it did is it used that what we call camel case, which is where every word is capitalized, and it puts spaces between it, and it always capitalizes the first one. So x speed, even though it was lowercase x, it capitalizes it, then puts a space, and then uses the word speed. Well, by default, it's set to 0. So if I go ahead and run my game, we're going to know that every frame it's going to add 0 to it. Well, that's not what I'd like to do, so let's speed it up. I can go forward, I can go backwards. Right, so I can change it as I'd like. Pretty cool. So that gives me an idea of how to move it. But the real issue is that this speed is really dependent, if you think about it, on how many times the frame is called. Let's get back to Visual Studio. And so if this frame, if the game for some reason is running too fast or too slow, well, this speed is going to be moving too fast or too slow. So it's not really quite what I'd like. Okay. So instead, I'm going to go ahead and define a new float. We'll call this delta speed, and we'll say x speed times time delta time. Now, this time delta time is a class, an object, and this delta time is going to be how much time has elapsed since the last call to the update method. And what I'm going to do is, because this is a number that is represented in seconds, this is going to be a very tiny number, a very small floating point number less than 1, and it's going to multiply x speed by that amount. And what this will do is make my x speed become something that is measured in units of seconds. So this will tell me how many units per second I'm going to move instead of just being arbitrary based on the number of updates that are getting called. So I'm going to save that again, and I'm going to run it. And you're not going to really notice a difference because you would only notice a difference if the frame rate was really crazy. But now it also gives me an idea of how fast this object should move. Whatever 1 unit is, it's going to move over 1 unit in 1 second. So if I make this 0.5, it's going to be really fast. Okay, I'm going to reset its position to 0. If I make it 0.01, it's going to move at a consistent speed across the screen. And that's how we set up basic behavior and basic movement. Now, if I come back over to my planetary behavior object and I wanted to say rotate it, I could just simply do a transform rotation, and I could do things. But there are other ways to do this. Like transform has methods on it that will let me call, how it's going to behave. So if I say transform.translate, what you see is that this is a method that's going to take a simple vector 3 and do all of this addition for me. Okay, so sometimes it's better to use these methods because it makes it a lot more apparent what you're doing. Here I have to read the code to figure out what's going on, and I have to hopefully have caught this little x speed here. But if I use the translate method, then it'll let me know and let the reader know immediately, oh, they're translating, and translating means moving from one position to another. And so it makes it very obvious. So I would highly encourage you not to use just position and change it, but to instead use the correct like translate or rotate methods to make sure that you're methods make sense and that your update makes sense to yourself, especially later when you come back to your code to figure out what's going on.